are CodeAnt AI, erasing world's tech debt, one function at a time. So, what is tech debt and why we are so concerned about it? Let's see. 40% of developers' time goes in dealing with tech debt. On an average, 60% of every dollar which is spent on IT budget is on tech debt. $85 billion is actually the opportunity cost per year for bad code which is written and pushed to production. So, what is a bad code? A bad code is something which is insecure, having security vulnerabilities, doesn't have code optimizations, and doesn't have a code standardization methodology. So let's give you a slight demo of what we mean by all these three things so that you understand it way better. So, in front of you, you will be seeing that this is a very generic fast API function, basically an API which is written. And you are seeing that there is a class of user and we are trying to log in something and then we are trying to extract some data. This is a very generic way how a code will be written by an SD1, SD2. Okay. But there's a lot of vulnerabilities into this. Let's see how we can find those in a single click. So in my VS Code extension, I'll just do Command Shift P and I'll say, first foremost, give me the security vulnerabilities. So I'll click on security. Let's see what happens. Okay, shoot, I'm getting so many errors in this. Let's try to understand what the error is and what can I do to fix it. So if I click on this bulb icon here, you'll be able to see, okay, it says that there's a possible SQL injection that can happen. Okay. And SQL injection is very common kind of a security vulnerability. It can happen to your databases so that any attacker will use username, password, and try to brute force in your systems. So if you compare this tool with industry leaders like Snick, what Slick will give you is basically somewhat kind of a thing of this where they'll be able to detect something. But we tried, it's not very granular. But the differentiation comes here that Snick doesn't give you a quick fix. Most often than not, what developers used to see is this big thing which is written out here. Again, I, as a developer, have to go and search for this and try to fix it. Okay, but at CodeAnt, we believe that we have to make things which is very developer friendly. So in this, we have given two options. So either you can click on this and see real world GitHub actions, GitHub examples where you can relate, or you can directly click on this fix possible SQL injection vector and it'll automatically fix the issue for you. Let's try that. So it what it did was it basically parameterized the entire query so that SQL injection can't happen. Similarly, I'm seeing one exception here that I've written pass but not sure why it has given exception. Let's try to see it. So it tells me that okay, there's a possibility of a DDoS attack which can happen. And this is a very common attack again, and people forget it. Now we have to make sure that we don't flood our servers with the requests which we can't handle. And even when we are getting it, we need to log some kind of uh, action so that we are informed about it. Let's see how we can do it. Again, what I'll do is I'll click on this bulb icon and I'll press this. It'll fix this for me. Similarly, we have detected a secret. This is a very common practice in any company. You'll find hard coded secrets written left, right, and center. So it tells you that is a hardcode password. So you can click on this. It'll create an environment variable out of it and also give you basically a kind of a logic that you can export this. Similarly, if I'll click on this, you will be able to see a real world example. Plus, it'll tell you that you have written a get call, but you haven't added a basic retry, okay, or a timeout. These kind of very basic functionalities like adding a timeout, adding logging, adding making sure your code is not vulnerable enough, these are the things which are often missed. And even in code reviews we see that these things are not covered up. But imagine if you had something like code and sitting in your editor, the moment you'll click on that button, it will give you all the errors, plus it'll give you the fixes. Right now, we are detecting more than 40 plus security vulnerabilities, which enables you to scan around 80% of most common security attacks which happens. Next thing after code security is basically code optimization and readability. How do we make sure our code is optimized and readable across the organization? Right now at CodeAnt.ai, we detect more than 400 code inefficiencies and we also fix them. I'll just give you a quick demo. How do we go about it? Let's take an example. You are given this kind of a code. First thing which will come into mind is how unreadable this code is. You can't make sense out of it. Why? Because everything is cluttered. And if I have to review this code, honestly, I'll just do one thing, which is I'll just write looks good to me and approve that PR. This is the exact same problem which every company face. Why they face this problem is very simple. Every developer is different. The way they write code is very different. That is why there's a huge inconsistency in the code. This trickles down to a very unique problem, which is how much time does it take a new developer to onboard on a particular piece of code? That is pretty high if you have huge inefficiencies or inconsistencies in your code. But imagine you as a developer love to write code like this, and there's no harm in that. Why? Because your brain works in this manner. You don't want to optimize it. But what if I'll give you the ability that you can change this entire function into a very readable function in just a single click? Let's see how it works. In your VS Code editor, what you have to do is Command Shift P, and you'll see Quick Fix option here. Just click on it. This will transform your entire function into a highly readable function, and this will make way more sense. So you can continue writing the way you wanted, but in the end, before submitting the PR, you can just run this code into your entire code piece, and you'll be able to get a truly transformed function. This feature of ours is very different from linting. If you compare the solution with ESLint or SonarLint, they are actually just a tool for inundation. We have gone a step further and added way more functionalities into it. For example, adding comparisons, adding identity checkings, checking, making sure we are capturing exceptions, checking the casing, adding doc strings, etc. This is one thing. Another thing is if we talk to a lot of developers, one of the biggest challenge that they face is how do I make sure that I understand the entire flow of my code right now? And there's a lot of interswitching and new developers coming in, going out. How do I make sure that a new person coming understand the entire flow? For example, this is the code for bank account. If you see there's a class bank account, it has multiple functions: get balances, deposits, withdraws, validate amount, etc. As a developer, it will take me a good amount of time to understand this entire flow function, which function is calling another function. But what if I'll give you an ability that with a single click, you'll be able to understand the entire diagram of your current flow? Let's see how it works. Again, in your VS Code extension, do Control Shift P and click on Generate Diagrams. What it will do is it will create a class diagram for your entire class. Let's say banking. So it will create a banking.png. So it creates a very good diagram. It tells me that on line number 47, we are doing a transfer from function call, which is going to transfer to, it is going to deposits, withdraws and deposits. Withdraws, we are checking if he has a sufficient account. If he has, then we go and check balance and log the operation. So this kind of a flow is very intuitive. If you're given this kind of a code with this kind of a diagram, it enables you to understand code in a way better format, and everybody can understand it. Whenever an incident will happen, even a product manager or program manager can come and understand, okay, this is the flow. If this is breaking, automatically this entire thing will be breaking. Lastly, we'll be talking about code documentation and code best practice. Documentation is very essential for any software developer to understand what the code is doing and how he has to interact with that piece of code. More often than not, we find that proper documentation or doc strings are not available for every function, and manually it is not even possible. If we use open source tools for doc string generation, we find that it is not very catered to the actual function that you have written. It is a very generic input, output, and processing format, which doesn't make way more sense. That is why we need a very specially catered docstring for every function that you have written. And code best practice. This is a very big market altogether, and we don't find any big player trying to address this market. What is this? It's a very human tendency, which is that today, if we have to deliver a feature, and this goes in all startups and companies, that feature delivery always take priority. And at that point of time, nobody thinks about optimization and following the best practice. Everybody is just focused on delivering that particular feature, because of which what happens is your robustness and reliability of code goes down, takes a very huge dip. If you're writing an API, a very generic thing is you just try to ensure that API is functional enough. But who will take care of retries, back off delays, exponential delays, making sure it has rate limiting, making sure it is managing its tokens properly? These kind of things take a bait, and that is why it increases tech debt to another level. And we are solving this with a single click. Let's see how we are doing it. So let's come back to our banking class. In this class, you see that there's a lot of code which is written, but it'll be way more efficient for any developer to comprehend this code if a very detailed doc string to which is very catered to this function is written. And this is exactly what we give. For example, in this function, in this class, you'll be able to see every function which is written has a very detailed doc string. Let's say a function called withdrawal tells you that what actually this function is trying to do, tells you the parameters, and what tells you the return value. Similarly, the init function tells you that we are trying to initialize a bank account, and in the parameters telling that the initial balance is coming to zero. Where this value is coming from? This is coming from this initializer that you have given. So if you use a very out of the box docstring generator which exists, you won't be able to get this kind of detailed analysis, which is very specific to your function. But with our AI, we can generate this. This is one. Secondly, we believe that code reviews take a bait when you have to deliver features as fast as possible. That is why best practice are never followed there. Let's take an example of this. This is a very simple code which is written, and it is trying to do a ton of other things. It's trying to loop, trying to find out something, and trying to get the pricing of the fruit. So if I am a reviewer of this code, what I'll do is I'll just check if it is fulfilling my basic feature requirement or not. If it is, I'll just move ahead and approve that PR. But the problem is, in software, we say that shift left, find features, find vulnerabilities, find inefficiencies in the developer laptop altogether. Don't let that thing go in a code review state. Why? Because it will increase the back and forth. And when the back and forth start increasing, it is doing nothing but increasing your tech debt. Imagine if you had a feature or a power in your hand that you could have done Control Shift P in your VS Code editor and said that I want to make sure this code looks good. So I'll be clicking on code review first. Code review is completed and I see a lot of inefficiencies here. So one if inefficiency tells me that I'll click on this bulb icon again. It says that fix and try to use a generator instead of a list. It is very good insight in software engineering that you can always use a generator and it uses less memory than a list, and it gives you a fix also. So I just click on it, and these are very direct fixes, so you can directly go and fix it. Similarly, you are seeing an error here. I'll just click on it. It says that try to use a set instead of this array that we have created, which makes sense. If you use a set, we make sure that only unique elements are stored. And if we come to this part, we see that yes, uh, if we click on the bulb icon, it shows that okay, we should be using comparisons instead of doing this equal to, which is a good insight. Let's click on it. It fixes a function. This is how, with small incremental changes, we can make your code very efficient. And these incremental changes won't take more than 30 to 40 seconds to implement in your code base, but it's going to give you a ton of value. Lastly, we'll be talking about the best practice. Let's imagine that you're having a code like this. This code is basically an API call that you're trying to do, and you're trying to get the response back. To any developer, this code will look very fine. That yes, we are able to do a call, we are able to check if the data is 200. If it is 200, we are able to get some return the JSON out of it. Good enough. But what if the call that you're doing to this particular URL, any service which is hosting this, is down or is unresponsive? What will happen to your code base? Will you try to bombard that? Will you try to again and again reach that particular service? How will that work? This is where the difference between an SD1 and a principal engineer comes. Because a principal engineer understands that we need to make sure that the code is resilient and reliable. But in a team, the very nascent thing is we have, let's say, 10 or 20 SD1, SD2s. We'll be having only two or three principal engineers or tech leads, because of which implementing the knowledge that they have in the actual code takes a huge amount of time, and it's never goes into actual production because there will be a lot of back and forth. But what if, even if you're an SD1, I'll give you a very strong tool which enables you to understand these kind of vulnerabilities and add it in your code. So let's do that. I'll do Control Shift P and I'll click on best practices. What it did was it imported a module in Python, which is a tenacity, and it added a retry mechanism. What this retry will do is it'll try to do retry in in an exponential fashion from 1 to 30 seconds, and I'll try to make sure the max retry is 5. This is a very good code. Why? Because it makes sure that it is just trying 5 times in a duration of 1 to 30, and it enables you to make sure that your underlying or your downstream system never goes down because of you. These kind of understanding and knowing your code base is very important, and we want to make sure that we give this power to the developers in their editors so that they can make the code which is way more resilient, bug free, reliable, and it has a great readability and understandability. That's CodeAnt AI for you. Happy to connect and discuss. Thanks a lot.